Oh yeah? Okay. This is question 2019D from your textbook, which is Brown and others. We have a compound of arsenic reacting with nitrate ion to form I think it's called arsenic acid, and dinitrogen trioxide. So the first step in our reaction, in our balancing our redox reaction, is to separate the two half reactions. And we inspect it to see that anything that isn't going to be balanced using hydrogen and oxygen is balanced before we start, because if we start with those things wrong, then it's going to carry through. We'll have the wrong answer at the end. So we see that there's two arsenics on the left and one arsenic on the right here, so we're going to have to put a 2 over here. Same with this half reaction, 2 nitrogens have to be balanced off to give the dinitrogen trioxide. The next step, let's start balancing the first half reaction. We have 3 oxygens on the left and 8 oxygens on the right. So what are we going to do to balance that? 5 H2O on the left. That's going to create an imbalance of, well, there's 10 hydrogens here and 6 hydrogens there. How are we going to balance that in acidic solution?
Plus 4 hydrogen.
4 hydrogens on the right. Now we look at the charges. Did I copy it down correctly as far as charges are concerned? Let me just double check before we go and make a serious mistake. No, okay, good. No charge on the left, 4 pluses on the right. So what do we do to even out that charge?
Minus 4.
Minus 4, so we're going to put 4 electrons on the right. I think that balances the first half reaction. Now let's look at the second one. We have 6 oxygens over here and 3 oxygens over there. How are we going to balance that?
Plus 3 H2O on the right.
3 H2O on the right. That creates an imbalance of 6 hydrogens on the right.
Add 6 hydrogens on the left.
So we add 6 hydrogens on the left. Now let's look at the charges. We have 2 minuses, 6 pluses, so that's a net charge of plus 4. No charges on this side. How do we even out the charges?
Minus 4 on the right, left.
4 electrons on the left. So now we look at our 2 half reactions. We see that they both have 4 electrons, so we don't have to multiply them by any numbers to even out the number of electrons. We simply add the 2 half reactions. We can cross out the electrons before we even start adding them, and the result is, and also to shorten it, we can say, because we haven't had to multiply them, we can do some of the dirty work right in the half reactions. We have 5 H2Os on the left and 3 H2Os on the right, so that's going to come out to a net amount of 2 waters. We have 6 H pluses on the left and 4 on the right, so we can cancel those out and put 2 H pluses on the left. And then we can just write the final result, putting everything that's not crossed out below the line here. So we have As2O3, which was in the solid state. 2 nitrates, which are aqueous. 2 H2O liquid. Plus 2H plus aqueous. Producing the acid, which is likely aqueous. Plus the N2O3, which I think is a gas. Let's double check. No, it's aqueous. And that's our final answer for that equation in acidic solution. You see it says in acidic solution, and you have H plus in there. On the second example, it's going to be done in basic solution, so we're going to have an extra 2 steps at the end once we balance it. We first write out the half reactions that are involved. Bromate form. I'm going to leave out the state of each one because it just tends to clutter the calculation up. The manganese number of atoms is balanced, same with the number of bromine atoms. So let's start by balancing oxygens. 2 oxygens on the right, 4 on the left. How do we balance it?
2 H2Os on the right.
2 H2Os on the right, which creates an imbalance of 4 hydrogens.
4 hydrogens
So we're going to put 4 hydrogens on the left. The charges now. We have a net charge of +3 on this side, nothing on the right. How are we going to balance that?
+3 on the left.
+3 electrons on the left. That balances the charges. Now we have bromide being oxidized to bromate. How are we going to balance the number of oxygens? Yes? The 2 in front of what?
No, that's oxygen. Plus 3 H2Os on the left.
3 H2Os on the left, right. That creates an imbalance of 6 hydrogens on the left. So,
3 hydrogens on the right.
no, we're not 6 hydrogens on the right. 3 times 2 from the water. Let's check the charges now. We have +5 on this side, -1. How are we going to balance that? We're going to add 6 electrons on the right. That's going to balance. Another way of looking at it is say, look, these 2 are minus on this side, minus on that side. These tend to balance out. So you have an excess of 6 plus charges over here. Add 6 electrons and it counterbalances that. Now in this case, we need to multiply the first reaction by 2 so that when the 2 reactions mesh, as it were, sufficient electrons are generated here. This reaction uses 3 electrons. This one gives up 6 electrons. So this reaction has to run twice for it to drive this reaction once. So we'll write all the effects of that. We'll multiply that 2 in. So we have 8H plus 2 permanganates plus 6 electrons. Then we'll put the results of this plus bromide ion plus 3 waters. And that produces all of this, remembering to multiply these 2 by 2, 2MnO2 plus 4H2O plus the bromate plus 6H plus the 6 electrons. So right off the bat, we can cross off the electrons. There's 3 waters here, 4 waters there, that becomes 1 water on the right. 8H pluses, 6H pluses becomes 2H pluses on the left. And we can write the balanced equation in acidic solution, but we're not done yet. Now, if we want to balance it from acidic, turning it into a basic solution, what we do is we add the same number of hydroxides as there are H pluses. We do it to both sides. And when you combine the H pluses with the OH minuses, it turns into the same number of water molecules. Then we balance again the water molecules. See, we have 2 H2Os on the left, 1 on the right, so that reduces down to 1 H2O. Now let's write the result neatly. Let's state everything involved. 2 permanganates, aqueous, plus bromide, which is aqueous, plus water, which is liquid, produces manganese dioxide, which is, I have to double check that one, solid, plus the bromate anion, which is aqueous, and 2 hydroxides, which are also aqueous. That is a solution balanced in basic solution.